Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and, and your studies are also going on well. This is part 13 video on the chapter of probability, where I will be discussing about two more examples of random experiments and discuss their possible outcomes and the favorable cases of some events based on those two random experiments. So these are examples 3 and 4. In the previous video, part 12, I discussed about the example 1 and 2 random experiments. If you have not watched that video, I strongly suggest that you watch that video to have a good understanding of random experiments, possible outcomes and favorable cases of some events. Okay, so this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and once again, if you want to further support me, then please subscribe to my channel, and in that case, do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 13 video, where I will be discussing example 3 and 4 of random experiments along with their possible outcomes and favorable cases of some events based on those two random experiments. Sorry. Okay, so example 3 is the experiment is 3 unbiased coins are tossed simultaneously. Okay, so first, as usual, let's try to find all the possible outcomes. Okay, so there are 3 coins, so each individual coins can show up a head or a tail. So I will list all the possible outcomes. I hope you will understand. So let's say everything is head. All, all the coins are head. Okay, and let's say okay, and let's say the first coin is tail and the other one is again head. Okay, actually how do you decide, how do you know how many outcomes are there? You know that in the first coin it has 2 possibilities, head or tail. So 2 possibilities multiplied by the second coin will also have 2 possibilities, head or tail. 2. The third coin have 2 possibilities, head or tail. 2. So there will be 8 possible outcomes. Okay, now okay, we have this. Now let's say we have head, and then head, tail, and then we have head, tail, head. Okay, head. Let's systematically write the possible outcomes. Please give me some few seconds. Okay, so first one is head, and then we are keeping the first coin as head, and then we are finding all the possible outcomes of the second and third coin. So if we just consider the second and third coin, the possibilities are head, tail, head, and tail. So these are the 4 possibilities when the first coin is showing up head. Now if the first coin is showing up tail, we will have the similar outcomes just like the first 4, but the first coin will be tail. So tail, head, tail, head, tail, then tail, head, and then tail. So we have, these are the 8 possible outcomes. You can say these are the elementary events. Okay, so now I have defined some events. E1 is, the event E1 is 2 heads. So how many? So let's say what are the favorable cases, or the what are the elementary outcomes which is satisfying the condition of the event E1. So favorable cases of the event E1 if I represent that as set, so from the possible outcomes PO, which are the possible outcomes that will satisfy the condition of the event E1. So two heads. Okay, so I can have head, head, tail. I can have head, tail, head. I can have tail, head, head. I can have no more. Okay, so these are the possible outcomes or the favorable cases. There are three favorable cases to the sorry, to the event E1. Okay, so what is small m? What is the number of favorable cases of the event E1? M is equal to 3. Let's see what are the favorable cases of event E2. Event E2 is 0 tails. 0 tails. Okay, so we can have head, head, head. This is the only possibility. 0 tails means all heads or 3 heads. So M is 1. Let's see E3. Event E3 is at most 2 heads. So we can have 0 head, 1 head or 2 head. So what are the possibilities of, what are the possible outcomes having with 0 heads? It is tail, tail, tail. What are the possibilities, what are the possible outcomes which has 1 head? It is head, tail, tail. It is tail, head, tail and tail, tail, head. So there are m, small m for the event E3 is 4. Okay, let's see what are the favorable outcomes of event E4. Event E4 says all tails. So obviously all tails, there will there will be only one outcome, that is tail, tail and tail. E5. E5 says no tails. No tails means all heads. So head, head, head. So we can say that event E5 is equivalent or identical to event E5 all tails. No, it is not identical to any event yet. Let's see. Okay. Yes, what was E2? E4 is tail, tail, tail. Oh, E5 is no tails. Okay, no tails. So no tails, definitely then E5 is identical. No tails means 0 tails. It is identical to event E2. Let's see event E6. What are the favorable cases or outcomes of event E6? E6 says consecutive heads. That is, the heads must appear consecutively. Definitely we can have head, head, head. We can have head, head, tail. We can have tail, head, head. Tail, head, head. Yeah, only this one, only these 3. Head, 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 tail and tail, head, head. So okay, so for this one M is equal to 1. For E5 M is equal to 1. For E6 M is equal to 3. Consecutive tails. Similarly, the event E7 is consecutive tails. So what are the possible outcomes or the favorable cases of event E7? Consecutive tails. So we can have head, tail, tail. We can have tail, tail, head, and we can have tail, tail, tail. Here also M is equal to 3. The last event E8, it says at least one head. This is FC. Favorable cases, FC. Favorable cases or outcomes of event E8, that is at least one head. At least one head means we can have one head, two head, or or three head. So one head can be head, tail, tail. One head can be tail, head, tail, and one head can be tail, tail, tail. So these are the three outcomes which are having one head. Now it says event E8 says at least one head. So we can have two heads. So what are the outcomes, possible outcomes having two heads? It is head, head, tail, head, tail, head, tail, sorry, tail, head, head. Yes, tail, head, head. Now, okay. So what are the possible outcomes of three heads? At least one head means it can have one head, two head, or three heads. So what are the possibilities of three heads? There is only one, head, head, head. So for event E8, sorry, for event E8, M is 7. Now, if you are asked to find, okay, by the way, the small n, that is total number of possible outcomes of this random experiment, is 8. Now, what will be probability of event E8? It will be 7 by 8. What will be probability of event E5? It will be 1 by 8. What will be probability of event E3? It will be 4 by 8, which is equal to half. In this way, once you have found all the possible outcomes or favorable outcomes of a particular event, then you know the m, small m, and then from the empirical formula you can easily find the probability of an event, small m divided by small n, where small n is the total number of possible outcomes of the random experiment. So this was example 3. The random experiment was 3 unbiased coins were tossed simultaneously. Let's see the next example. Let's see the next example, example 4. In this random experiment, 2 dice are thrown simultaneously. Okay, so what are the possible outcomes of the random experiment? 2 dice are thrown. 2 dice are thrown simultaneously. Okay, so the first dice, we know that a dice has 6 numbers. When we throw a die, one number shows up. That is the the number on the top surface, top side. So since there are 6 sides numbered 1 to 6, the first die can show up any number from 1 to 6. So there are 6 possibilities, and the second die will also can show up any number from 1 to 6. So there are 6 possibilities. So there are total 36 possibilities. So which means that for this random experiment, the total number of possible outcomes is equal to 36. Now it will be difficult to okay, anyway, let's write down the possible outcomes. It will require more space. Okay. So the first number, let's say we fix the die, the first die can show up any number from 1 to 6. Let's say the number showing up on the first die is 1. Okay. Now I am denoting an event, not event, an outcome as 2 numbers separated by a dash, which means now 1 dash 1 means the first die is showing the number 1 and the second die is also showing the number 1. Okay, so keeping the keeping the number showing up on the first die as 1, I will change the number showing up on the second die as from 1 to 6. So now 1 2, 1 3, 1 4, 1 5 and 1 6. So these are the 6 possibilities, possible outcomes when the number showing up on the first die is 1. Similarly, I will now if I So if the first die is showing up the number 2, I will have 2 1, 2 2, 2 3, 2 4, 2 5 and 2 6. Now if I show the first die, let's say, I hope you are getting the point, you are getting the idea. This way I will have the first die will let's say the first die is showing up the number 6. So I will have 6 hyphen 1 comma 6 6 hyphen dash 2, 6 dash 3, 6 dash 4, 6 dash 5 and 6 dash 6. These are all the possible 36 possible outcomes of this random experiment where we are throwing 2 dice simultaneously. Okay, now I have defined some events. Even sum of the numbers, by sum of the numbers I mean the numbers appearing showing up on the top face of the 2 die. So sum of the numbers is even. So out of this 36, so what will be okay, I think I will require more space. So what are the possible outcomes that are favorable to the event E1? That is, the sum of the numbers is even. Sum of the numbers is even. If I consider the first row, the outcomes of the possible outcomes from the first row, I can consider 1 hyphen 1. The sum of the numbers is even. Let's try to apply some little bit of mathematics. Now, when can we know that the number on any of the 2 dice is from 1 to 6. So when can the 2 numbers, their sum will be even? Either they are both even or they are both odd. Then only their sum will be even. Okay, so what are the possibilities? 1 1, they are both odd. 1 is odd, 1 is odd. I can have 1 3, I can have 1 5. Okay, now I can have either they are both odd or they are both even. Okay, I can have 2 2, I can have 2 4, I can have 2 6. Then then I can have 3 3 1, I can have 3 3, I can have 3 5. Then I can have 4 4 2, I can have 4 6 5, I can have 1 5, I can have 3 5, I can have 5, and then 6 I can have 6 2, 6 4 and 6 6. So how many outcomes are there which are favorable to the event E1? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So m is equal to 17. Now if I I could be doing some silly mistake doing the basic calculation and counting. If that happens, then please feel free to let me know in the comment section. So the idea is that how will I choose which are the possible outcomes, which outcomes of all the possible outcomes will be favorable to the event E1. Event E1 is sum of the numbers on the 2 die is even. So 2 numbers can be even when they are both even or they are both odd. So in that way we have to choose the outcomes. Okay. So quite obviously then a probability of the event E1 will be 17 by 36. Let's see, sum of the numbers is odd. I think it will be same as sum of the numbers will be odd when the two numbers showing up on the two die will be one will be even and one will be odd, then only their sum will be odd. So in that way you can easily choose which of the possible outcomes will be favorable to the event E2. Sum of the numbers is a perfect square. Let's see what are the favorable cases of the event E3. Sum of the numbers is odd. Sum of the numbers is a perfect square. Okay. So what are since there are 36 possibilities, which means that obviously the sum, if you take the sum of the numbers showing up on the two die, it will range from 2 to 12. 2 to 12. Okay. Now no, we have to be careful. Okay, so what are the possible outcomes where the sum of the two dice, the sum of the numbers showing up on the two die will be a perfect square? So the numbers, the sum of the numbers will range from 2 to 12, and the numbers, integers which are perfect squares between the two integers 2 and 12 are 4 and 9. Okay, so these are the two. Now what can be the numbers showing up on the two die so that their sum can be 4 and 9? One can be 2 2. Another can be 3 1. It can be 1 3. So these are the three possible outcomes where the sum of the numbers showing in the two die is 4. Now what are the what are the outcomes where the sum of the numbers showing up in the two die will be equal to 9? It can be 3 6. It can be 6 3. It can be 4 5. It can be 5 4. It can be only this one. So in this case, small m is the number of favorable cases to the event E3 is 1 2 3 4 5 6 7. 7. So probability of event E3 will be equal to 7 by 36. Let's see what are the favorable cases for event E4. Product of the numbers is less than 9. Okay. E4, event E4, we have to consider those outcomes from the possible outcomes where the product of the numbers showing up on the two die is less than 9. So what are the combinations? Let's see. Okay, so if I consider the number showing up in the first die is 1, then I can have 1 1, I can have 1 2, I can have 1 3, I can have 1 4, I can have 1 5, I can have 1 6. Okay. Okay. I can also have 2 1, I can also have 3 1, I can also have 4 1, I can also have 5 1 and 6 1. Let's see if I can have also 2 2, I can have 2 3, I can have 2 4. If you multiply, you can see in all these outcomes, if you multiply the two numbers, they will be less than 9. Now 2 2, 2 3, 3 2 4. 2 3 can also be 3 2, and 2 4 can also be 4 2. What else? It can be 3 3. It can be 3 3. I think these are all the possible outcomes. So what is M? What are how many What is the number of favorable cases? What is the number of favorable cases to the event E4? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17. So the probability then of the event E4 will be 17 by 36. These are some example events I made up. There could be many other numerous events based on this random experiment of throwing 2 die. I hope these 2 examples will give you a good clarity of how we are identifying the all possible outcomes of a random experiment, and given some event based on the random experiment, how we are finding the favorable cases, or how we are finding which of the possible outcomes is favorable to a given event, and then using the empirical formula, what will be the probability of that event. In the next video, I will discuss a few more examples, and then I will move on to solve problems based on these concepts. So, so if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.